Who this book is for? This book is for web developers interested in exploring scalable vector graphics. This book is for web developers interested in exploring scalable vector graphics. It's written for the perspective of a front-end web developer, but anyone with expertise with JavaScript, CSS, and XML-based grammars should find this book accessible. Prior experience with SVG is not required. What this book covers: Chapter 1, Introducing Scalable Vector Graphics. Introduce the basics of SVG and will show you some fundamental example of working with the format. Chapter 2, Getting started with authoring SVG. Introduce the fundamental concepts for authoring SVG in detail. Chapter 3, Digging deeper with SVG authoring. Introduces more advanced concepts for authoring SVG, including transformations, clipping and masking, and importing SVG elements into a document. Chapter 4, Using SVG in HTML, and adds further details about using SVG elements and SVG images in HTML documents. Chapter 5, Working with SVG and CSS introduce the reader to using SVG images in CSS, replacing PNGs and GIFs in the modern web development toolkit. This chapter also introduces the many ways you can use CSS to modify SVG elements. Chapter 6, JavaScript and SVG, teaches the reader the basic JavaScript SVG application programming interface by introducing the common document object model methods that allow a developer to access and manipulate SVG properties. Chapter 6, JavaScript and SVG, teaches the reader the basic JavaScript SVG application programming interface by introducing the common document object model methods that allow a developer to access and manipulate SVG properties. Chapter 7, Common JavaScript libraries and SVG, teaches the basic of interfacing with SVG from common libraries and frameworks, including jQuery, AngularJS, Angular, and React.js. Chapter 8, SVG animation and visualizations, looks at example of doing visualizations and animations with SVG. Chapter 9, Helper library snap.svg and svg.js, looks at two current libraries that help with common SVG tasks, snap.svg and svg.js. Chapter 10, Work with D3.js, introduce basic uses of D3 and walk through some simple examples in order to whet your appetite for this powerful library. Chapter 11, Tools optimize your SVG, focuses on the different tools available to optimize SVGs. To get the most out of this book assumes that you have knowledge of HTML, XML, CSS, and JavaScript. Knowledge of Node.js and NPM-based development is also helpful. Before you get started, it will help to ensure you have Node.js installed. You will also need to test editor. The samples in the book were written with Visual Studio Code, but any text editor will suffice. Download the example code files. You can download the example code files for this book from your account at website. If you purchase this book elsewhere, you can visit the website and register to have the files emailed directly to you. You can download the code files by following these steps. Log in or register at the website. Select to Support tab. Click on Code Downloads and errata. Enter the name of the book in the search box and follow the on-screen instructions. Once the file is downloaded, please make sure that you unzip and extract the folder using the latest version of the software. The code bundle for the book is also hosted on GitHub at code. In case there's an update to the code, it will be updated on the existing GitHub repository. We also have other code bundles from our rich catalogs of books and videos available at the website. Check them out. Download the color images. We also provide a PDF file that has color images of the screenshots, diagrams, or diagrams used in this book. You can download this here. Color images. Conventions used. There are a number of text conventions used throughout this book. Coding text indicates code words in text. Database table names, folder names, file names, file extensions, path names, domain URLs, user input, and Twitter handles. Here's an example. Mount the downloaded WebStorm 10 DMG disk image file as another disk in your system. A book of code is set as follows. When we wish to draw your attention to a particular part of a code block, the relevant lines or items are set in bold. Yes. Any command line input or output is written as follows. Bold indicates a new term, an important word, or words that you see on screen. For example, words in menus or dialog boxes appear in the text like this. Here's an example. In this document, we've created a stylized letter R. Warnings or important notes appear like this. Tips and tricks appear like this. Get in touch. Feedback from our readers is always welcome. General feedback. If you have questions about any aspect of this book, mention the book title in the subject of your message and email us at customer care at pactpal.com. Errata. Although we have taken every care to ensure the accuracy of our content, mistakes do happen. If you have found a mistake in the book, we would be grateful if you would report this to us. Please visit the website, selecting your book, clicking on the errata submission phone link, and entering the details. Piracy. If you come across any illegal copies of our works in any form on the internet, we would be grateful if you would provide us with the location, address, or website name. Please contact us at copyright at packet.com with a link to the material. If you are interested in becoming an author, if there is a topic that you have expertise in any, you are interested in either writing or contributing to the book, please visit the website. Reviews. Please leave a review. Once you have read and used this book, why not leave a review on the website that you purchased it from? Potential readers can then see and use your unbiased opinion to make purchase decisions. We at Pact can understand what you think about our products, and our authors can see your feedback on their book. Thank you. Introducing Scalable Vector Graphics. Scalable Vector Graphics (SVG) is one of the most powerful components of modern web development. If used properly, it can solve common problems relating to the design, development, and delivery of imaginary and user interface. SVG is an XML-based markup language used to define images. While HTML is to text, SVG is to images. SVG is very flexible. It can be implemented as a standalone image and used as the src as the source of an image, or as a background image, or as a background image in CSS, such as PNG, GIF, or JPG. It can also be embedded directly into an HTML page and manipulated with CSS or JavaScript to create animations, visualizations, and interactive charts. So, if SVG is that important and can do so much, why isn't it even more widely used? Why does it feel like we are only scratching the surface of what's possible with it? Why does it still feel like a new thing? The problem is, not everyone knows everything that SVG is capable of, and not everyone who knows what it is capable of is able to implement SVG solutions in an optimal manner. This book aims to help everyone interested in using SVG to get over those hurdles and master this vital technology. SVG has had a circuitous route to its place in the pantheon of modern web development technologies. Released in 1999, it's older than HTML. SVG languished for a decade because of lack of support in the dominant Internet Explorer browsers. The technology started to gain favor several years ago with JavaScript libraries such as Raffle, which added programmatic fallback support for older versions of IE, and the chain has only grown stronger since. Thankfully, the tide has fully turned. All modern versions of Internet Explorer and Edge have support for SVG, and there's strong support for the technology from all browser manufacturers, including, of course, Chrome and Firefox. By the end of this chapter, you will understand the basic of SVG in its many guises. You will be able to take existing SVG images and use them in web pages and CSS with confidence, and you will be well on your way to the promised land of SVG mastery. This chapter will cover the following topics: introducing to fundamental SVG grammar and vector graphics in general, the why and hows of using SVG as the source file of an image, basic usage of SVG as a CSS background image, the benefits and differences of using SVG embedded directly in a document, a brief introduction to modern and feature detection, creating a simple SVG image. If you are at all familiar with HTML, then the basis of an SVG document are going to be familiar to you. So let's get the mystery out of the way early and take a look at a simple SVG document. The following code sample shows the basic structure of SVG. The first element is the standard XML declaration, indicating that the following should be parsed as an XML document. The second element is where the form begins. It defines the root SVG elements in the same way that there's the root HTML elements in an HTML document. Height and width define the intrinsic dimensions of the document. The XML namespace is a reference to the schema that defines the current XML element. You'll learn about viewbox in more detail in the next chapter. There are many other attributes possible on an SVG element. You will learn more about them throughout this book. In this first example, following the SVG element, there's a single SVG test element. The test element, like the SVG element, has many possible attributes that you will learn about as you make your way through the book. In this case, there are 4 attributes related to the display of the element. The X and Y attributes represent the position of the top left corner of the text element as points on a coordinate plane. Font family maps to the familiar CS property of the same name and defines the specific font that should be used to display the text. Font size also maps to the common CSS property of the same name. The attributes that accept length values. In this example, width, height, and font size are provided without a unit. For example, px, pixel, em, and percentage. When these values are presented as attributes, the unit is optional. If no unit is provided, the values are specified as being user units in their user space. You'll learn more about the way that values are calculated in SVG throughout the book. For now, just remember that in practice, user units will be equivalent to pixels. Finally, there is the content of the text element, the simple message "Hello SVG." Saved as the code, saved as the file, and opened in a browser. The previous makeup renders as in the following screenshot. Now that you've seen the most basic example of an SVG document, let's take a look at the basic usage of SVG images and elements in a variety of ways. Using SVG as a content image. In this section, you will learn about the single most basic usage of an SVG image. Using it the same way you would use a JPG, PNG, or GIF as the source of an image element. If you've done any work with HTML at all, then you will know how to do these things. It's just an image element, but you should start to think about all the different ways you can use SVG, and this is a big one. Looking at the following code sample, there's nothing special at all about the image element. There's an src pointing to the SVG image, height and width to define the image's dimensions, and an alt attribute to provide a texture representation of the image for screen readers and other cases where the image may not display. Running the preceding code in a browser renders the following. One thing that might be a slight problem is that not all web server by default set the correct mini type for SVG. If the mini type is set incorrectly, some browsers will not display the SVG image correctly. As one common example, Microsoft's IIS may need a specific configuration setting change to properties of SVG's images. The correct mini type is image /SVG plus XML. Drawing with code. Before you learn about other basic implementations, it's worth taking a look at the previous screenshots in a little more depth. Instead of just being tested like the first example, which after all you could have just done in HTML. It shows 4 circles diagonally arranged across the canvas. Let's take a look at the source of that image and learn our first visual element in SVG, the circle element. The following code sample shows the circle in action. It also shows how simple changes in makeup attribute values can create visually interesting patterns. In it, there are 5 circle elements. These all take advantage of 4 new attributes. Cx and Cy represent the center x and the center y coordinates of the element on a coordinate plane. R represented the radius of the circle. Fill defines the color that will fill the color. Fill accepts any valid CSS color value. In this case, we are using a red, green, blue, alpha RGBA value to fill this with variations on poor red. The first few values remain the same, while the fourth value, the alpha, doubles every time from .1.125 to 1, fully opaque. Similarly, Cx, Cy, circle x, circle y, and r and radius double each time. This produces the pattern you saw earlier. This isn't the most elaborate SVG images, but it does show you how easy basic SVG elements are to use and understand. Scalable plus Vector SVG plus Vector Graphics. Now that you've seen an example of drawing created with SVG, it may be useful to take a second to explain the vector graphics in SVG and why that makes the file format scalable. With raster bitmap file formats, you are probably familiar with formats such as JPG, PNG, or GIF. You can think of the image data as being stored pixel by pixel. So each point in an image is stored in the file and read out by the browser or graphics program pixels by pixel and row by row. The size and the quality of the image is concentrated by the size and quality at the time of creation. There are optimizations for all the bitmapped file formats that limit the actual amount of data stored. For example, GIFs use the LZ77 algorithm to collapse redundant pixels down to a backpoint and reference pixel. Imagine if your image has 100 pixels of pure black in a row. The algorithm will search through the image for a sequence of same bytes, and when a sequence is encountered, the algorithm will search backwards through the document to find the first instance of that pattern. It will then replace all those pixels with instructions, a back pointer on how many characters back to search, and how many pixels to copy to fill in the number of same bytes. In this case, it will be 100 pixels to search and 1 pixels to copy. Vector graphics, on the other hand, are defined by vectors and control points. To simplify significantly, you can think of vector graphics as being a set of numbers that describe the shape of a line. They may be a set of specific points, or they may be, as in the case of the circle earlier, a set of instructions on how to create a specific type of object. The circle element doesn't store every pixel that make up the circle. It stores the arguments used to create the circle. Why is this cool? One reason is that because it's just a set of instructions defining the shape, which you can scale in or out, and the rendering image will just calculate new values accordingly. For that reason, vector graphics can scale infinitely without loss of fidelity. If that's all confusing to you, don't worry about it. The more you work with them, the more familiar you will be with the way vector graphics work. In the meantime, the following set of examples and figures will help to illustrate the difference. First, look at the following makeup. It represents 4 images. Using the exact same SVG image as the source. The image represents the SVG logo. The dimensions are set at the image's natural size and length 2x, 4x, and 8 scalable. The image natural size. Rendered in the browser. The lab makeup produces the following. Notice that the completely crisp all the wake up to 8x the original size. Now look at the same makeup, this time with PNGs. It follows the same pattern. But now see the result. Notice that at a natural level, there is no difference between the SVG and PNG. The pixels in the PNG are through to match the vector-defined lines in the SVG version. Also notice how the image gets progressively worse as the image gets larger. There is no way for the browser to get more information out of the bitmap format to fill the detail at a large size. It simply scales up the pixels that it has, with terrible results, especially at 8x level.